In this factoring example, we will completely factor this polynomial in front of you. Anytime I see a polynomial that has 4 terms, I instantly think about factoring by grouping or potentially using the rational zeros test. So this one will factor by grouping, so I will take a common factor out of the first group, being x to the 4th, leaving me with a 2x squared plus 3. Out of the second group, you can factor out a negative 16, leaving you with a 2x squared plus 3. Now these sets of parentheses should match. If you try to factor by grouping and they don't match, then you cannot factor by grouping and you'll have to use the rational zeros theorem. From here, you can see the 2x squared plus 3 is one factor. They're in common now in both of those terms, leaving you with an x to the 4th minus 16. Now, you can see 2 terms with opposite signs, and they're both easily square rootable. So this left factor will turn factor again here, x squared plus 4 and x squared minus 4. This first factor is still there, but this happens again with the x squared minus 4. These are both easily square rootable, so make sure you do it again. So this would be 2x squared plus 3 times an x squared plus 4 times an x squared, just an x plus 2 and an x minus 2. And from here, you can set each of these factors equal to 0, but for this one, it is quadratic, so you'll have x squared plus 4 equaling 0. You can subtract 4 from both sides to get x squared equaling negative 4. You can then take the square root plus or minus in front of the number to cancel out the square and be left with x equaling plus or minus 2i. The negative becomes an I and the 4 becomes the 2. The zeros from these two factors are relatively simple to find, x equals negative 2 and x equals 2. And if you follow the same solving process that I showed here for this one, you should get 2 zeros of x equaling plus or minus I root 3 over 2.